Mass and weight are two words that are used pretty interchangeably in everyday language, but they mean two very different things. And in physics, we need to be sure that we are talking about precise definitions. So mass versus weight is what I'm going to be talking about in this short video. So as we talked about, relating to Newton's first law, we mentioned that mass is a quantitative measure of your inertia. Mass is in kilograms. So I'm going to just say like inertia, and it's in kilograms. Right? It's a fundamental property of a body, of your body. Your body has mass, it has a certain inertia. Mass is related to inertia by just giving it a number. Weight, on the other hand, is the gravitational force that the Earth exerts on you, or the nearest planet or surface that you're on. So weight is a force. Very, very different than the concept of inertia, mass. It's a force. And it's the gravitational force that that the surface that you're on, the body, the planet that you're on, or wherever, exerts on you. I'll say gravity of planet. Right? It's one thing for Earth, it's another thing for other planets. Do not use these terms interchangeably. The reason that they're used interchangeably in common tongue is because if you're always talking about Earth, then the force, right, the force due to gravity is always going to be whatever the mass is times g, and if g is always, if you're talking about Earth, it's 9.8 meters per second squared, then the mass is the thing that determines the force, given g being the constant thing. But specifically in physics, g is not the same everywhere, right? This is g for Earth is 9.8. Gravitational acceleration due to Jupiter happens to be, Jupiter is bigger than Earth, and it pulls you at a higher acceleration. Jupiter, g, right, is 24.8 meters per second squared. So it matters. It matters. Don't use these terms interchangeably. Weight depends on the body that's gravitationally acting on you, and mass is a fundamental property of your body. If you want to do something fun, you can do a quick calculation for if you jump upwards. So if you apply a force upwards on, let's say this is Jupiter, right? Say equal to 50 newtons, 50.0 newtons. And this is Jupiter, so G, and I'll do a little J there, is equal to 24.8 meters per second squared. And find out what your peak height is, right? So find out your y when your Vy is equal to 0, yeah? And then do the same for Earth. If you jump the same force, you apply the same force against the Earth, right? F equal to, where G is equal to 9.8. meters per second squared. And you can see the difference. So your weight, you obviously weigh something different on these different bodies because the acceleration is different. And so when we talk about weight, like this, right? I said that some books do this. It's acceptable, but you have to know that it's equal to the force, right? And G needs to be specified where you're at, right? Or it's assumed to be Earth. But that's why weight is equal to F, which is not equal to M. It's equal to M times G.